So today we will continue our discussions, and we will finish the lecture 1. The last part will be the semiconductor industry and market. So if you look at the worldwide semiconductor revenue, this is back in 2020. So the total semiconductor market is about like 466 billion. So I would believe that this year probably is over 500, even 600 billion. So it's a huge market. And then if you break down the market into the standalone memory, so here specifically we're looking at the standalone memory like the DRAM and NAND flash. So it's about like 27%. And if you further break down the DRAM and flash, it's roughly half and half. So this is all about the market. And then you may wonder where is the SRAM? So as you know, SRAM is embedded memory on chip, on the same chip with the processor. So SRAM is embedded into this part. So of course, as we discussed earlier, you also look at the examples of those processors. More than 50% of the footprint occupied by the SRAM on those processors. So you can imagine the revenue of the SRAM. So this is a huge market. And then let's look at the overall semiconductor industry models. So first of all, we have the companies working as foundry. Okay, foundry only does the manufacturing from the designs of other design houses. So the leading foundry, of course, is TSMC. TSMC, if you look at the foundry market share, TSMC occupies more than 60%. And then we have Global Foundry and UMC, SMIC, and so on. Those are second tier, third tier foundries. Basically, TSMC dominates the market. And then we have many fabless companies. Sometimes we also call them design house. So they only do the design and send the layout to the foundries for manufacturing. And as you know, AMD, NVIDIA, those are, the top ones. And also Qualcomm, Broadcom, and also MediaTek, and many others. So those companies only do the design. Of course, they need to have very good relationship with the foundries. And in many cases, they do this DTCO, design technological optimization, with the foundries together. And then there's a third category. This used to be, the dominant ones, but nowadays, fewer and fewer companies follow into this IDM, integrate device manufacturing. So in this case, Intel is the leading IDM. But of course, you may read the recent news. Intel is planning this IDM 2.0 strategy, which means Intel is actually going to be split in some sense into two, subdivisions. One is Intel Foundry. That means Intel Foundry will also get the orders from other customers. And then Intel will also send their designs to other foundries for manufacturing. For example, Intel's latest processors are made by TSMC. So this is a cross point for this IDM kind of working model. And Samsung is also another IDM because Samsung does everything, Samsung does everything basically. But Samsung's major business, of course, Samsung has a foundry, and actually the second largest foundry, followed by TSMC. Samsung foundry's market share will be like 15–16%. But then Samsung's major revenue comes from the memory business. And here the memory companies Those are the major vendors for the memory. Here, when I talk about memory, I mean standalone memory, like DRAM, NAND flash. So Samsung, SK Hynix, Micron, those three offer both DRAM and NAND flash. And then Western Digital and Kioxia offer the NAND flash. So the memory companies do not have the foundry or fabless model because memory companies, they always do everything. I mean, from the design to manufacturing of the memory components by themselves. They do not offer, for example, the process design kit (PDK) for others to design or tape out with the memory technology. They do everything, close circle. And then another category is this automotive electronics. So there are many vendors for those electronics used in the automotive industry, and they all have design and manufacturing together because they may have some special processes. For example, TI, NXP, ST Microelectronics, and so on, and Renesas, I think, from Japan. So they all belong to their, let's say, most of their products is about the automotive. And then I just added the last category. So you may see that more and more system or software internet companies actually start designing hardware, designing their custom chips. So Apple, as you know, they have their own silicon, and Google has their own silicon team. Meta has their own silicon team, and you can also name like even Tesla, Amazon, Microsoft, and so on. So they all hire in this area. And of course, I didn't list the enabler for all those designs, which is EDA vendors, right? So in this ecosystem, then we need the EDA vendors. You may have already used many of those softwares from Cadence, Synopsys, or Mentor Graphics. So any questions about this landscape? Okay, so then let's look at some historical trend in terms of the semiconductor sales revenue. And this was back in 2006, 2006. So here, this is the top 25 companies in terms of the revenue. At that time, you see that Intel was number one, Samsung was number two, TI, ST Microelectronics, which is based in France and Italy, and then Toshiba, and then TSMC, and so on. So you may see, some names like that, and some of those companies may not exist today, like Freescale today is already acquired by NXP, and that's the ranking at that time. And then I will flip the slide, so you will see the changes over the years. So this was back in 2006, and then this is 2010. So one notable change is that you see TSMC is ramping up, and I think TSMC started, getting more and more attentions around that time. And also you see for the first time Qualcomm here jump to the top 10. This is a starting point of this mobile phone business. And then we still have the, memory companies, Micron here. Yeah. And of course, number one, number two, always Intel and Samsung. And then let's look at 2014. You see big changes, right? Of course, Intel, Samsung, historically always there. And then TSMC jumped to number three. And the Qualcomm, this is the peak of the Qualcomm, 2014. The smartphone, is just right at the peak. And then Micron acquired Epida, which is a Japanese memory company. So Micron, after the acquisition, then become number five. And then for the first time, you see SK Hynix, which is a Korean-based memory company. jump to top 10. And then Japanese company Toshiba keep declining. And then, yeah, that's basically the trend. And I just want to point out some companies you may know today, actually 10 years ago, was here, MediaTek, AMD, NVIDIA. Okay. So then 2016, not too much changes from 2014. Still, you see Qualcomm, Broadcom, they're at the top. And then memory companies are not doing well, are doing pretty well, like SK and Micron. And NVIDIA rank jumped a few spots. And 2018, SK ramped up, and then still Micron's here. And then you see for the first time, NVIDIA moved to top 10. And then Qualcomm, start declining, as you can tell the reasons from the market. 2020, okay. Still at 2020, first two, over the past 20 years, no change. Intel, Samsung. And then 2020, you see memory companies are doing pretty well. SK and Micron here. Of course, TSMC is number 3 here. And then NVIDIA ramped to number 8. Okay. This is the latest data last year, because 24, is not finished yet. 23, this is that's the latest ranking. Of course, the news from Intel is not doing very well, and TSMC really, jump over, right, become number 1. And you see NVIDIA from the past, 2 or 3 years, look at stock price, what happened. So in terms of revenue, also number 3. And then AMD, right, also doing pretty well, right, also in top 10 now. So that's basically what the industry, evolved over the past 20 years. Of course, here I'm not judging, the companies, right? But this is what the history tells you. Any questions? So still memory companies, I think they have good share in the top 10. Like, Samsung mostly memory, because Samsung Foundry, I mean, the revenue is insignificant compared to the memory. And then we have the Micron and SK, especially SK Hynix is doing pretty well because of the HBM, because of the NVIDIA has exclusive agreement with SK. So NVIDIA's GPUs, DRAM all come from SK. So that's why SK Hynix really benefits from that. Okay. So here a quick summary. So if you recall last lecture, we talked about the technology node. That means nothing. It's a market symbol. What matters for the logic scaling is a contact gate pitch and M1 pitch, and also how many M1 track you use for the standard cell. So here, standard cell height reduction is a key enabler for the integration density improvement in the recent technology nodes for the logic, okay? And then for the memory, the technology node, like for DRAM NAND flash, is more related to the smallest feature size, that is physical, half pitch of the metal one wire, or the, let's say, the poly pitch or the 2D NAND flash. And then we see the technology trends for the logic scaling. for the future. Right now, we're at FinFET, okay? And industry started transitioning to the stack nanosheet. Samsung already does that. And then we will see that other companies will follow. And eventually, there will be this CFET, NMOS on top of PMOS. That may happen after 2030. But this is a foreseeable technology trend. So memory is still very important. Many top 10 vendors purely are memory companies. So any questions here? Okay, so then we will stop.